Well, the last time we were in class, we started to play around a little bit with some phenomena that helped us begin to understand that air pressure is all around us. Even right now, you are being affected by air pressure. There's atmospheric pressure, in other words, there's little molecules of air stacked upon each other all the way up into the atmosphere. And as they get higher and higher, there are fewer and fewer of those little molecules. But down here on the Earth, there's a lot of those molecules pushing down on us, and that's called air pressure or atmospheric air pressure. And that is constantly pushing on our bodies. But our bodies are also pushing back against that so we don't feel that air pressure pushing on us. It's kind of like we talked about with the third law of motion, where every action had an equal and opposite reaction, so that things stayed, if there was more action one way, there was always something pushing back, like a ball on a table. The ball's pushing on the table and the table's pushing on the ball. Well, in this case, air pressure is pushing on us and we're pushing back on that. So it's important to keep in mind that air is always around us, but we're always pushing back on that air. Then what's very interesting is scientists have actually measured the force of air. And while I normally in science class like to talk in metrics, today I'm going to talk in English units because it will make more sense to you. So this little red square right here is 1 square inch. Scientists have measured that the pressure of a column of air on 1 square inch is 14.7 pounds of pressure. So that means on this little square, there's 14 pounds of pressure pushing on it. But in the case of a piece of paper, there's also 14.7 pounds pushing this direction on that square inch and this direction on that square inch. Now, when we took those cards last week and put them on top of a cup of water and turned them upside down and then let our hand away, the card wasn't 1 square inch. It was probably closer to this size right here, which has 5 square inches this way and 5 square inches this way. So what would the total area of this piece of paper be? I'm going to let you figure that out. It's a really simple math problem, so get your calculators out. You don't even need a calculator for this one, actually. But how many squares are on this piece of paper? Then I want you to figure out, if air pressure is pushing at 14.7 pounds per square inch, how much pressure is being exerted on this entire piece of paper? I want you to do that math in your notebook. Once you've done that, go on to the next page. So here's a picture again of our cup in the upper left-hand corner with that card over the top of it. Roughly speaking, a cup of water weighs about 1/2 pound. But you just found out that air pressure is pushing up on the bottom of that cup on the card, holding it in place. So there's 1/2 pound of water that gravity is acting on up here, but how much did you find was actually being pushed up by air pressure on the bottom? Well, once you figured out those two numbers, that should begin to explain why the card was able to stay on the bottom of that cup, even though there was water above it. Same thing's true with the straw and the water in the straw. I would like you to go to a website that I have back on the assignment page, and I want you to read about the sections called Ocean of Air Pressure, Measuring Air Pressure, Winds, and then Measure the Wind. This is a great little website to talk to you about atmospheric air pressure. It will help begin to fill out some of the understanding that you need about air pressure, and we will do lots more investigations, and I'll show you some other phenomenon when we're in class again this week. Make sure you're taking notes in your notebook, and I'll see you soon. Bye.